All right, I'm on page 5 of your packet, and we're going to be taking notes on measures of dispersion. So this is going to be going over how consistent your data is, or how much does your data set differ from the mean. So this says spread, by the way. So we're going to be examining how the data is spread out or dispersed about the mean. So dispersed and spread out are the same thing. So we're going to talk about 4 different ways that we can examine how the data is spread out. The first way, which you guys probably know already, is called the range. So what the range does, it takes the minimum value, so the whiskers of our box and whisker plot. So it takes the minimum value and the maximum value, subtracts them, and voila, we have our range. So this one is definitely the easiest measure of dispersion. So now before we go on to 3 other methods, we're going to go over a couple vocabulary words. And one is talking about population and one is talking about sample. It's really, really, really important that you guys know the difference. Population is talking about everyone in whatever, so for example, if you're talking about like the United States, you'd be talking about, for the population, you'd be talking about the entire population of the United States. If we were talking about the population of Latinos living in Los Angeles, that means you'd be literally talking about every single person who identifies as Latino in Los Angeles. If you are talking about a sample, that means you're just taking a sample from that. So if your study is talking about people in the United States, and you know you can't survey every single person in the United States, you can't sample the entire population, what you do is you create a sample. And you create a random sample. Remember, randomization is important so you don't have any bias in your study. So that means you just take a random sample from people in the United States, and you can make inferences that, well, because my sample said this, that means that the entire population will also have that same trend. Yes, it is an estimate, but it's a pretty good estimate as long as you don't have any bias, as long as you your choices are random and they have a wide range of types of people. So let's talk about symbols as well. So if we're talking about S squared is for the sample, which this here is, we're talking about an omega, so we can talk about the population from which the sample was taken. All right, population form should be used unless you know a random sample is being analyzed, and this is because of biases. Obviously, it would be ideal in every study to have the entire population, but in a lot of studies, you can't survey the entire population, so you have to go with a sample. All right. Now, let's talk about the other 3 types of measures of dispersion. So one is called mean absolute deviation, MAD, or Mothers Against Drunk Driving. No, in this case, it's mean absolute deviation. And this is the mean of the absolute value of the difference between the individual values in the data set and the mean. I'll explain that in a second. Variance is using, notice that there's 2 different equations for each one of these: population variance and sample variance. So they do have they differ by this n minus 1. So for sample variance, we're going to have to subtract n minus 1, or divide by n minus 1. N is the total number of terms in the data set. We'll do an example if this is a little bit over your head. And n is the total number of data points. So when you're doing when you are taking the variance of a population, you divide by n. When you can't survey the entire population and you just have a sample of the population, you have to divide by n minus 1. Same with standard deviation. The only difference between variance and standard deviation is standard deviation takes the square root. All right. So let's do two examples that will go over variance, standard deviation, and mean absolute deviation. Because looking at these equations, I'm assuming most of us are a little bit lost at this point. All right, number 1. Find to the nearest tenth the standard deviation and variance of this distribution. Now let's first try and comprehend what this table is saying. So we have different scores here, but we also have a frequency. What this frequency means is 2 people had a score of 100. So I'm going to actually write this out. So if 2 people had the score of 100, I have 2 100s. Only 1 person got a 200. 3 people got a score of 300. 1 person got a 400, and 1 person got a 500. Now, if we're trying to see how these data points vary or differ from the mean, how spread out they are, then the first thing we have to do is calculate the mean. Remember, mean, the symbol for mean is this X with a little line on the top of it. So we calculate the mean by adding up all these points and dividing by n, the number of points. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 points. So I'm going to add up each one of these points and then divide by 8. So if I have, I'm just going to add up the numbers. So if I have 100 plus 100 plus 200 plus 300 plus 300 plus 400 plus 500, that gives us 1900. So now I have 1900 divided by 8. I know 19, so that's going to give me 237.5. Sorry. So this is my mean. So when we're talking about standard deviation and variance, I want to figure out how far apart these data points are from this mean. So let's first calculate the variance. So I'm going to go to my variance equation. And the question is this population variance or sample variance? Because I have the entire data set, I'm not choosing specific values from the data set, I'm going to use the population variance. So for this population variance, remember this sigma from a couple units ago means sum. So that means I'm going to take this equation, add them up for every single term, and then at the end, divide by n. Remember, n is the total number of data points I have. All right, so let's do an example. My formula for the variance, the population variance, was I'm going to add up x minus the mean, square them, and then I'm going to divide everything by n. So let's do that. I'm going to take a data point, 100, subtract it from the mean, square it, add that to another data point, subtract it by the mean, square it, take the next data point, subtract it from the mean, because I'm trying to figure out how far each one is from the mean. So I'm going to do this for all the data points. And it doesn't matter if you're going to have negatives because you're squaring it. So when you square a negative anyways, it's going to become positive. So I'm going to keep going until I get to my last data point. Oops, I had another 300 there, huh? All right, when I finish that for all my data points, oh, sorry about that. My last step is to divide that whole thing by n. N is the number of data points I have. So 1, 2, 3, 4, 5, 6, 7, 8 data points. So this is where the calculator is going to come in handy for you. Oh, excuse me. So I'm going to have 18906.25 plus 18906.25 plus 1406.25 plus 18906.25, and there's 1, 2, 3 of those, so I'm just going to multiply that by 3. If that confuses people, I'm sorry. So 300 minus 237.5 is what I did. Oh, did I make a mistake here? Shoot. Yeah, I did. My bad. Okay. Yeah. This should be, my bad, 3,906.25. And I'm going to multiply that by 3 because this 300 is the same here and here. So I'm going to have 3 of those. And then I'm going to do 400 minus 237.5 squared, which gives me 26406.25 plus 500 minus 237.5 squared, which gives me 68906.25. Check my work, guys, make sure I'm right. And then dividing all this by 8, so I'm going to add these up. So I get 146,250 divided by 8, which gives me 18281.5. So 18,281.25 for the variance. Now, the standard deviation is this number and the square root of that number. So let's look at the difference between variance and standard deviation. So my variance, I took the difference from the mean and squared everything and added everything up. The population standard deviation is doing that exact same thing except squaring it. Square rooting it. Sorry, so I'm going to take my answer for my variance. This should be squared because the variance is squared. So that means my standard deviation is equal to the square root of my variance. Which is going to be 135.21. So what this is saying is, on average, each point on average is going to differ from the mean. My mean is 237.5. On average of 135.21. This is actually a really big standard deviation. So they deviate a lot from the mean going up and down. All right. I'm going to stop there, and we will do number 2, the mean absolute deviation for these numbers. If you would like to try this on your own, then you're using this equation. So you're taking the value, subtracting from the mean, taking the absolute value, and then dividing by n.